Air Force Small Business Innovation Research (SBIR) program has funded many critical and commercially successful technologies to help advance its programs and facilities. The Arnold Engineering Development Complex, for example, has achieved a number of crucial technological solutions through SBIR projects.
AEDC is the world's largest complex of aerospace test facilities. It encompasses wind tunnels, rocket cells, engine test cells, space chambers. Really virtually anything that flies has come through AEDC.
We are always looking for ways to leverage innovative technologies, innovative concepts to make our processes better. And SBIR provides a tool for us locally to do exactly that.
Small Business Innovative Research, or SBIR program, is a program that's congressionally mandated. It's administered by the Small Business Administration, and it's executed by numerous organizations throughout the federal government, including the DoD, Air Force, and AEDC. We put out topics based on mission need, testing need, that kind of thing, and small businesses propose on those topics.
Small businesses can sometimes bring a solution that we simply hadn't thought about.
Through the SBIR program, companies like Innovative Scientific Solutions, Inc., Mechanical Solutions, R.J. Lee Group, Active Signal Technologies, and Propulsion Science and Technology have developed innovative solutions for AEDC. Pressure-sensitive paint, or PCP, is a technology AEDC has been developing for 20 years. More recently, Innovative Scientific Solutions, Inc., ISSI, created an advanced version of PCP.
The fast-responding pressure-sensitive paints, the polymer is modified so that the oxygen or the air can move very rapidly through the surface. You spray a paint on the model, you light it up with a light, and you take a picture with a camera, and now I get millions of points on the model surface rather than hundreds or even 1,000, so I get continuous maps of the pressure distribution on the model surface.
The AEDC facility is home to a host of rotating machinery, most notably the equipment that drives its 5 wind tunnels. Through several SBIR contracts, Mechanical Solutions developed condition monitoring software to track the health of this equipment.
We are providing Arnold with our health monitoring software, which we call Sentry. So you've got your machine that's running, and then we'll have sensors attached to it, and those wires will be coming into a data acquisition system. And then that data acquisition system will do some amount of processing and send that information to a computer where our algorithms can now go to work on it. We're helping them keep their machinery reliable.
Data collected from testing and research at AEDC is stored in various databases and computers with many operating systems. R.J. Lee Group created a new information management system called TDAS to improve the data gathering process. TDAS stands for Test Data Aggregation and Analytical System.
The goal of it is to make usable all of the data they have. Imagine a location where they have 50 years worth of test data, but they can't find it. The goal of the SBIR was to find a way to make that data searchable and usable and identifiable so the engineers could have it at their fingertips. And that's what we put together with that program.
In 2013, AEDC approached Active Signal Technologies, AST, to create a new fuel valve and actuator system to improve the effectiveness of simulated missile plumes, which are used to test anti-missile defense systems.
One of the challenges that we've had historically is to be able to expand and contract the plume depending upon the stage of flight that the missile you're simulating is in.
We had developed an actuator under our own funding that was critical to the operation of the valve. Without the SBIR funding then coming from the Air Force, we would not even know of this particular application, let alone try to meet the spec that they had.
With the support of the SBIR program, Propulsion Science and Technology, PST, developed computer-simulated missile plumes to vastly improve the warning sensors used to protect aircraft from surface-to-air missiles.
We create models that are designed to simulate missile plumes. So the Air Force uses these images of missile plumes to feed the development of early warning sensors that they put on aircraft to protect the warfighter when it goes into a dangerous situation and there could be threats looking to shoot them down. The more they know about the threat, the better they can design those sensors, both the hardware and the software that's used to identify the threat.
We're making a difference in our country. That's where we find our pleasure, we find our joy, and our sense of accomplishment.
SBIR program has allowed AEDC to be able to continuously improve our test techniques, instrumentation and diagnostics, and other technologies that are required to test the next generation of weapon systems and commercial vehicles that come through our facilities.
Because at the end of the day, that's really what we're looking for, is a successful end product to be able to do our mission better here at AEDC.
The collaboration with the Arnold Engineering Development Complex is a perfect example of how the Small Business Innovation Research Program helps the Defense Department meet its better buying power goals of controlling costs while getting effective new technologies into the hand of U.S. warfighters. Learn more at www.afsbirsttr.com.